We are talking about a cone today. Yes, we are going to focus in on right cones, but that definition is in general for a cone. Lateral area is the area of the shape without what? Sorry, the surface area of the shape without what?
Edges.
Nope. 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 What part of surface area do you take away just to get the lateral area? What part is not included?
Base.
The base. So, we're focusing in on lateral area first. Now, when I unfold my cone, what does the lateral area look like it's creating? Not three-dimensional. It almost looks like it's starting to form a circle, almost a half a circle, but is it truly kind of getting that half circle? Is that a diameter? Not quite. So, it is getting part of a circle, but not a full circle. I don't have a great descriptor as to why this is the formula for lateral area, but it's pi RL. What's the R stand for? Radius, which you would find the radius of the cone on its base. What does the L stand for?
Lateral height.
Nope.
Oh,
Slant height. So, cone has the challenge similar to pyramids in the fact that there are two different heights. There's the slant height, which goes down the side of the shape. And then there's the true height, also known as altitude, which will go from the vertex being a corner of a shape, and it will go from the vertex down to the base. Now, when we do our cones, similar to the idea of cylinders, it is possible to get cones that are slanted. But for the sake of using our formulas, we are going to deal with just the typical cone where the vertex is directly above the center of the base. So when you look at our true height on our shapes, it is going to go straight down to the middle of the circle. Now, surface area, just like all the others. I've got two formulas for it. One we're never really going to use, but I do still show it to you. Again, what's the difference between surface area and lateral area? Surface area includes what? Lateral area gets rid of it? The base. How many bases does a cone have? One, which means surface area is that singular base plus the lateral area. Now, cones share a property with pyramids. Or not with pyramids, I meant to say with cylinders, don't mind me. They share a property with pyramids, but we're going to come back to that property. Struggle bus. They share a property with cylinders. The way that cylinders differentiated themselves from prisms is the way that cones differentiate themselves from pyramids, and that is the base. Nice thing about the bases of both cylinders and cones is it is always a circle, which means when I talk about my base area, while I can talk about it as its own thing, most of the time I just use the formula for the area of a circle. How do you find the area of a circle? What's the formula for it? You should have a formula sheet on your desk. I'm sorry. Pi r squared. So pi r squared is the base area, and the lateral area we said was pi rl. Units that go with surface area and lateral areas are units what? Squared. Now, here's what I was trying to get at earlier that I all of a sudden realized was not actually what I wanted to talk about at the time. One of the things that I showed you with our pyramids is that if the pyramids have congruent bases and congruent heights, they essentially fit inside one another. The pyramid inside the prism. And we just started lopping parts off, and you could create the pyramid. Cylinders. Congruent circles. Would you agree? Same height? Same thing. I can stick a cone inside of a cylinder if it's got the same height and the same base, assuming it stands straight up. And I could just start lopping off parts of the cylinder to make the cone. Now, I showed you with pyramids visually with water how much of the water was left inside the pyramid, or sorry, how many pyramids could fill up the prism. That's what I did. How many cones do you think will fill up the cylinder? 3? Do you think it's the same as the pyramid? 3 pyramids filled up one prism? 3 cones fill up one cylinder?
Yeah.
If you believe that, you are correct. Now, much like with cylinders, there are 2 volume formulas. There is that 1/3 base times height, similar to that of pyramids, but again, we have that characteristic that is shared between cylinders and cones, that base is always going to be a circle. And therefore, I don't have to write capital B. I can write 1/3 pi r squared for BH. What kind of units go on a volume? Units cubed. So, lots of similarities when working with cones, to working with cylinders, and to working with pyramids, but they have their own formulas. So, keep doing what we're doing. When it comes to, the first thing you should look at is, what shape?
Right cone.
A right cone, technically, but I'm okay if you just go with cone. Being a cone means surface area formula, pi r squared plus pi r l. Volume, 1/3 pi r squared h. What does the 4 represent on this cone? Now it is pointing to this dot. Generally speaking, when it points to that dot does not have a number. What it's actually pointing to when it points to the dot at the center of a circle is it's pointing to whatever line is on that circle. Technically segment. It's pointing to this. What is that?
Diameter.
Do I want diameter?
No.
I want radius.
So it's 2.
Yes, since the diameter is 2 radius, I can do a little bit of math and say, okay, my radius is 2. What is the 6 pointing at?
True height.
The true height. What letter is true height? H, because it is going from vertex down to the middle of the cone. Now, I say down, but is it always going to go up and down? No. I can lay cones on their side. which means the 6.32 that's over here is pointing to what?
Lateral.
The slant height.
Oh, yeah.
This height.
I don't know why I keep saying
Probably because it's an L. That actually probably is why it's an L in hindsight. Lateral height. You're probably hitting on exactly why that is. Once you've identified those three things, these formulas are much like yesterday. Plug the numbers in. It's an ugly looking formula, but it is very calculator friendly. Pi times 2 squared plus pi times 2 times 6.32. And I just type that entire thing in. Rounding to the nearest hundredth. 52.28 meters squared. Volume, also not quite as pretty of a formula as yesterday's, but it's not a bad one either, as long as you're plugging the right things in. How do I put 1/3 into a calculator? 1 divided by 3. If you are worried about the fraction causing issues, put it in parentheses. It's not the end of the world on this one if you don't. Times pi times 2 squared times 6. Volume is 25.13 meters cubed. How are we feeling so far?
Fantastic.
Hopefully not too scary so far with cones. Is that a cone?
Yes.
Okay, so I got another cone. Brody, what is the formula for the surface area of a cone?
Pi r squared plus pi r
L, yes. Nate, what's the formula for the volume of a cone? Starts with a fraction. 1/3. Now we could go with base, but what's the base shape? Nate? Circle, so pi r squared. And then h. Jocelyn, what measurement do you see first? Tell me what one of these numbers represents. 5 is radius because it's going halfway across the circle. I didn't give you the diameter this time. Jasmine, what about the 8? That is the slant height. Are we missing something? The true height. When you are missing something, what shape do you use to help find it? You use a right triangle. Cones are a lot like pyramids. There are right triangles built in, connecting the radius, the slant height, and the true height of the shape. So sometimes you're going to have to use those right triangles to your advantage. On my right triangle, just pulling it off of the picture, you don't have to, but if it helps you. On that right triangle, I know that this right here is 5. I know that this right here is 8. I can use x on the other side, or I can use the variable I actually want it to be, h. I'm going to use h. Vivian, what is the Pythagorean theorem going to look like for that right triangle? What squared plus what squared equals what squared?
H squared plus y squared.
Good. We have to be careful to make sure the hypotenuse is what's going in the C part of a squared plus b squared equals c squared. That is still something a couple of you are tripping up on. Now, we've got time today, so we're going to go through the full Pythagorean theorem on this one. Greta, if I want to do Pythagorean theorem, what's the next thing I do once I write the equation? If I want to solve this, what do I do next? I do 5 to the power of 2, and while I'm at it, 8 to the power of 2. I square the things. Cam, what do I do next if I'm trying to solve that?
Subtract 25.
Subtract the 25. $39?
Yep.
Colin, how do I finish it?
Square root it both sides.
Do I need the plus or minus?
Yes. Well, no.
No, because I'm solving for a length on a cone. A height specifically. Heights are never going to be negative. 6.24. Now I have all of my variables. So, I start plugging things in. Charlie, if I plug things into the surface area formula, what's it going to look like? Tell me what to write as my next step. Starts with pi.
Yeah.
Times.
5 squared plus 5 times 8.
Good. Don't forget the time symbols after pi's. Before pi's, the calculator understands. After, some of them do, some of them don't. Now, some of y'all's calculators are fancy, and if you type that into your calculator, it's going to give you 65 pi. If it does, find the little either F to D or S to D looking button. It's typically either here, or sometimes it's over on this side of the numbers, or sometimes it's along the left. Pi times 5 squared plus 5 times 5 times 8. $204.20 meters. Is it squared or cubed? Squared. Lily, what's the volume formula going to look like?
1/3 pi times 5 squared times 6.8.
Good. Don't forget the pi. I'm not sure if you said it.
Yeah, I did.
Okay. 1/3 times pi times 5 squared times 6.24. 163.36 meters cubed. Don't forget the meters part. That's one other thing that I've seen a couple people doing, is they just write the cubed. We got one more that looks like this, and then we got a couple working backwards problems. Would y'all agree with me that this is a cone again? Therefore, my formulas have not changed. Do you have to write out on every shape what the shape's name is? No. Do you have to write out the full formula without numbers plugged in? No. Do I recommend both of these things?
Yes.
Absolutely. Trey, what is the 20? It's going to be our diameter. I don't want diameter. If diameter is 20, radius is 10. Connor, what is the 22.4? Slant height, that's L. I'm missing something again, aren't I? I'm missing the true height. Do you see the right triangle? For some people, it's a yes. They know exactly where it's going to be. For some people, it's not. Where would the true height go? Starts at the vertex and goes straight down to the middle of the circle. If I draw that in, can you see a right triangle popping up now? Right triangle. This is a 22.4. There's the right angle. Here's my height. What's this? 10. It's a radius. Always going to be the radius on the cones. Elena, what would our Pythagorean theorem look like then?
H squared plus 22.4 squared equals 10 squared.
Ooh, be careful. Which side's the hypotenuse?
22.4.
Yep, so that has to go in the C part of Pythagorean theorem. So it's not plus 22.4 squared, it's plus 10 squared equals 22.4 squared. This time around, y'all trust my Pythagorean theorem?
Yep.
Beautiful.
I guess.
20.04. Other than that, everything else is going to look the same on this problem. We plug in pi times 10 squared plus pi times 10 times 22.04. This time around, even if you got the fancy calculator, it is probably not telling you this in terms of pi because of the decimals. You're going to get 1006.5. Be careful of your rounding. 5.6?
Wait, Ms. Benson.
5.7. What?
That L is slant height, right?
Yes?
You put 22.04.
Which was the slant height. The true height was 20.04.
You put 22.04 on there, yeah.
Yeah, which is the slant height.
It's 22 point.
It's 22.4.
Oh, whoa, 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 whoa. I'm seeing what you're pointing out. There's no zero. That's gonna change the answer. You saw nothing? Good catch. 1017.88 kilometers squared Be careful, don't do what I did. As in, like, write the wrong number in. And my true height had a 0 in it. Not my slant height. 1/3 times pi times 10 squared times 20.04. The key thing I wanted to practice on this one really was that Pythagorean theorem piece again, and recognizing that the radius was the bottom of that triangle. Hence, I'm just going quickly through this part. Last thing you're going to see is the same as what you've been seeing the last couple times. Some work backwards problems. Haley, you still awake over there? You start them the same way. Shape. Cone. Cone gives me two formulas. I can write them both down and then cross one off, but I don't have to write them both down every single time. I can just go with which one it makes more sense to use. Does it make most sense to use the volume or the surface area formula here? Why?
Because
It gives you surface area. So, S equals pi r squared plus pi r L it is. S was 89.54 plus, not plus, what am I doing? Benson, get it together. Equals. You're doing nothing. Pi times. Do we know the radius?
3.
Yeah. 3 squared plus pi times 3 times.
X.
This is our slant height. It's going along the side of the shape. Much like before. On these problems, we generally should simplify first. Can I simplify this entire side? Altogether, that is. No.
No.
The moment you see a plus sign, you should be weary of simplifying. Is there a variable involved in this side? Yes, which means you cannot simplify it altogether.
Yeah, come on, guys.
You simplify this part. You simplify this part separately. Pi times 3 squared and pi times 3. Don't forget to put the x. If I want to solve this, what do I have to do next?
Subtract 28.27 from 89.54.
Okay. Can I just add the 9.42 and the 28.27?
No.
No, that would be the problem that wouldn't allow us to simplify it earlier. That's got an x, that doesn't. Do not combine unlike terms. Multiplication holds things together. Addition somewhat separates them when it comes to that idea of like terms. $61.27 is equal to 9.42x. Divide.
Yep.
X will be 6.50. No, you don't have to write the 0. Am I going to write it to indicate that I rounded to get it? Yeah. Centimeters. Final problem doesn't have a picture.
Don't need one.
You don't need one, you approach it the same way. What shape is it? It says cone. It tells you volume, which means we're going to use the
Volume formula.
volume formula. Volume for a cone is this. Do we know the radius?
No.
No, it's what we're trying to solve
That's
for.
gotta be X.
So we're going to put an X there. Do we know the height?
Yes, 4.
That says altitude though.
True height.
Altitude is height. Now in this problem we could not simplify that entire side all at once because there was an X separated from a plus sign with something without an X. Can I simplify this entire side if I want?
Yeah, so we can take the three symbols with numbers, or well,
I can take the numbers because it's all multiply. It's the plus sign that causes separation. Pluses and minuses cause issues with combining like terms. When it's all multiply, it all goes together. Take the numbers. Leave the squared alone. For some reason, people all of a sudden are like, well, I need to put that squared on something. It was on the X, not on the numbers. I get 4.19 x squared. How do we solve for x? No. What was that? Divide and then square root. You gotta get the squared part alone before you go taking square roots. $674.80 equals x squared, and then square root, yes. X will be 25.98, and it's a radius, so it's in inches. Guess what?